This is lesson 4.3. We talked about functions on Friday. We're going to continue with that on this. And I'm going to try to simplify this down as simple as possible so that it is, you can get through these worksheets that you are being assigned today. And I'll try to make it quick as well. You have this notation. This is called function notation when you have f of x is equal to something. And it's really the same thing as what we've had in the past when we would have had a problem that said y equals 15x and solve for y. Solve for y when x is equal to 4. And what we had done in the past, we had taken that value of 4 and we substituted it in. And then we'd have y is equal to 15 times 4. So y would be equal to 60. Okay, so this notation is just shortening that up. And so what it looks like is this. If I were to put it in this kind of notation, it would be f of 4 equals 15 times 4. So I replace the 4 with the x here. So I'm replacing the 4 in the x there. And so I can show then f of 4 is equal to 60. That's it. That's all it boils down to. Down here on the example at the bottom, you have f of negative 3 is what you're wanting to find. So we're going to plug in negative 3 for that x and there. And that is what you see in this step at that point. F of negative 3 is equal to 2 times negative 3 plus 1. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. Okay, so a couple of examples of the type of problems you'll see. Here is our function. They want us to solve for f of 2, so I'm going to go f of 2 is equal to, and then plug in 2 for x. Remember that I like you to use parentheses when you plug in. It helps keep signs lined out. So f of 2 then is equal to negative 2. That is your answer. That's all there is to that. It's not a complicated type of thing. You're just substituting in this value for your x here and your x there. So we'll do the same thing on b. You need to plug in the 11 here and here. The only thing different with b is it has a fraction, so we're going to have to do some fraction stuff. So f of 11 is equal to 1/2 11. I'm going to go ahead and put 11 as a fraction since it's being times by 1/2 plus 5. So f of 11 is equal to 11 over 2 when we multiply, plus 5. Got to get a common denominator. So f of 11 is equal to 11 over 2 plus, need to write 5 as a fraction, multiply both of those by 2, gives me a denominator of 2. That's 10 halves, so f of 11 equals 21 over 2, or 10 1/2. Okay. Again, I would be fine with you leaving that as an improper fraction. That's all there is. It's not anything difficult or tricky, just plugging those values of x in. We're going to also show this in table form. So if we read, you can organize the input, the rule, and the output into a function table. That's what this is down here. This is a function table. The domain is the independent variable. That's what we've always used as x. Okay, and they show that here. There's nothing, they're not being tricky about that or anything. It's the independent variable, it's x. And so then the range we know to be the y, and now in this notation that they're showing us, since they're using f of x, that's our f of x column instead. But it's still just like your x and y. Okay? So then the directions on this example says choose 4 values. That means you get to pick the values you put in for your independent variable and for your domain. So the book, you can see, chose the values of -2, -1, 0, and 1. They just you can pick whatever you want. I would have chose 0, 1, 2, 3. You get to choose when it says to choose. You really get to do that. Then they filled in the rest of the chart, once they get those, by substituting in the value of -2, since that's the x. That's going to be f of -2, so you put in -2 here. That's what they've done. -2 plus 5 is 3. So your f of x is equal to 3, or f of -2 is equal to 3. Then you plug in -1 plus 5 is 4, 0 plus 5 is 5, 1 plus 5 is 6. That is your function table. The last thing that they're asking you to do is state the domain and the range. The domain are your x values. What x values did they put in? -2, -1, 0, and 1. What were the range values that it kicked out by applying that rule? 3, 4, 5, and 6. Again, it's not hard, it's not tricky, it's just a different notation. So on this got it problem, here's our function that we're applying. We get a pick. It says choose 4 values. So I'm just going to pick the values of 0, 1, 2, and 3. Now I put those into my rule. So I'm going to put 0 in for x. So I have 0 minus 7 is 7. Then I put 1 minus 7. Oh, sorry, 0 minus 7 is -7. 1 minus 7 is -6. 2 minus 7 is -5. 3 minus 7 is -4. So the last part then is to state your domain. The domain 1, 2, 0, 1, 2, 3, and then state the range. The range that I get is -7, -6, -5, -4. Depending on the values you choose for your domain, will determine your range. And you may pick values that are different than what I chose on these. And that's okay. As long as you do your arithmetic correctly, then your domain and your range will be fine, whatever you get. Okay. So one more example of the solving for f of x. If I have f of x is -4, and the rule, or the f of x, is x plus 8, then I'm just going to rewrite this as f of -4 equals -4 plus 8. And that is 4. So f of -4 would equal 4. Okay, so work hard on those worksheets. They shouldn't require a great amount of effort to get through those if you understand you're just plugging in for x. So work hard, be good.